Now the same, in the previous video we looked at t-test. In the previous video we looked at testing for significance of regression using a t-statistic. The same test can be performed using f-statistic also, and they both are interrelated. The f-statistics is given by MSR over MSE. So we can look at MSR. We can get the MSR value either from the data analysis regression output or from the table that we set up early on. So MSR is right there, then MSE is right below it. So that's our F statistic. Now note that this F statistic is nothing but the t statistic squared. So you take the t value from here, square that, and that would be exactly equal to the f value. And you can get this f value from the data analysis results also, as I mentioned. So here it is. So here is the f value from the ANOVA table for regression. So the degrees of freedom, the numerator degrees of freedom is the degrees of freedom for regression, and the denominator is the MSE degrees of freedom. So MSR degrees of freedom is here, and then D71 is the degrees of freedom for MSE, the denominator. So F table value is F dot INV dot RT, the right side value, alpha, comma, numerator degrees of freedom, comma, denominator degrees of freedom. Okay. So that's the F table value, and we want P value, then we get F dot dis dot RT, the calculated F, comma, the 2 degrees of freedoms will give you the P value. Of course, this P value will be exactly same as the P value we got for the t-test. And again, the P value is from the ANOVA table as well, from the data analysis results. You see the significance of F, that is the P value. So the conclusion is exactly same as before. It has to be, because these are interrelated. So F statistic is greater than F table value, so we reject. Or P value is less than alpha, so that also, of course, reject. And then we interpret. We have sufficient sample evidence to conclude that the regression between the annual sales as the dependent variable, that is the Y variable, and the size of the profiled customers as the independent variable is significant. So the probability that this conclusion is wrong, that is the type 1 error, is nearly 0.